Good morning and welcome. Thanks for coming to the Summer Fellows presentation. This is a very exciting day for us and hopefully for you too. We're really anxious to hear about all of the great work and learning that you've accomplished during your brief time with us. This is one of the programs that I think we're probably most proud of collectively as the lab and the Cooperative Institute, largely because we get to work with such outstanding young scientists from throughout the country, and we hope that this program has been rewarding to you and that it's given you a chance to advance your understanding and education of what's out there and research possibilities, and kind of helps inspire you to complete the next phase of your career. So we hope that you've gotten a lot out of the program. We very much look forward to hearing about what you've been working on. Logistically, I'm just going to introduce you by first name, and I would ask that each speaker start by introducing themselves and who they've worked with, who their mentors were, and what the project was as you start your presentation. So we're going to start with Alex.
All right, welcome everyone. My name is Alexandre, most known as Alex here in the lab, and this summer I was working with Ann and Gia Wang in the Great Lakes Ice Data ArcGIS scripting. This was my first project, and after doing that I started working with George as well in the other project with the GLC, Great Lakes Surface Environment Analysis, and the ice cover, which I will talk later. So starting with the first project, introducing it, I would like to mention that the ice cover maps provides the basic data used to provide information to a broad audience of users and decision makers. For example, search and rescue operations, commercial shipping, and recreational ice fishing during the winter season, and also research on improving the prediction of ice cover in response to a changing climate on seasonal, interannual, and decadal timescales. And the goal of this project was to automate the way ice cover maps are created. So starting with the methods, the files I use to work with are comma separate values, as known as CSV files, and it has more than 1 million rows, so it's a big file, and the headers consisted by position, JI, coordinates, XY, and ice concentration, 0 to 100%. So when I got here, Ann told me like when she would load the file in ArcGIS, it took too long, so she advised me to try to remove the land before putting the file inside ArcGIS. So in this image, you can see like the -1 values represent the land, and the non-1 values represent ice concentration. So what I did, the first part of my script is to remove the land, get rid of the land, and after doing that, it reduced approximately 7 times the file size. After doing that, I put the file inside ArcGIS, and I used 2 different tools. The first one is Make XY Event Layer, which creates a new point feature layer based on X and Y coordinates. And the second one is the Cop Features tool. It's copy features from the layer to a new feature class. So I would have the shape file. After doing that, I just import a map and symbology from another map, so I would save time with that, so I don't have like to put the map layouts such as legend and title, so I would save time with that, and also the symbology. And after doing all of that, I just save the map and I export as JPEG, so people can access the graphic files in the Gluro website. And moreover, I was able to create the ArcGIS tool, which looked exactly the same as the other ArcGIS tools. And it has just one input, which is the main file with the land. So the script run everything at once. It gets rid of the land. It makes the XY event layer. It copies the features. It saves. It exports. And everything takes about 34 seconds. So my output would be this map. I just put one map because it would change just like the ice concentration, so it would be like boring here. So I just put one for as example. And in conclusion to this work, the automation of the process reduced by 81.5% of the waiting time for each day of the winter season. In addition, I created another script that can be run as a loop, so more files can be run at once. And finally, it permits faster analysis and availability for the public in GLUR website. And for my second project, I will talk about the Great Lakes Surface Environment Analysis and Ice Cover. So the Great Lakes Surface Environment Analysis is a digital map of surface water temperature of the Great Lakes based on satellite data imagery. And on the other hand, the National Ice Center is almost the same thing, but for ice concentration. So starting with 2008, GLUR has combined files of surface water temperature and ice cover that are useful for model verification. So with that, the goal of this project was try to combine both data, the GLC with the NIC from 1995 to 2007. Starting with the methods, the first issue we faced on this project, like the files, the old files, the NIC ice files, are in a different format. They are smaller and they have different resolution from the 1024 by 1024. So we had to convert them to the original file size. And I put this image because looking from here, you can say like the lakes look similar, they look alike. But when you zoom to a specific area, let's say for Lake Superior area, you can see like tiny difference between them from the NIC old file with a new one, nowadays one. So what I'm saying, in any way you try to convert the file, rescale the file, resample the file, you would have problem like with the coastlines, with those pixels that wouldn't match. And the same thing happens to the GLC file, so they differ. So that's a problem that I would be talking later. For now, I'll talk about the process that I did. The first tool I used in ArcGIS was the rescale tool. How I determined that those numbers, the X and Y scale factors, I had a guess, which is this image. The smaller one is the 516 by 510, and the bigger one is the 1024 by 1024. So I just realized, like, if I match the corners, the legs should match, but it actually didn't work very well because I was getting a lot of land values inside the water. So I just started guessing values until I got the lowest amount of land values inside the water. And after doing that, I used the resample tool to make the files with the same resolution, which is 1800, and the resampling technique I used was nearest neighbor. After doing that, so I was interested about the lake, so I used the GLC mask to extract the values that are inside the lakes. And I had the coastline issues that as I mentioned previously. So in this slide, you can see the red values represent land values that are falling inside the water. So it was about 2,000 values. So we had to fix it. And a way that I found to fix it was like interpolation. So what I did, I got the closest values to the land values. I got like the nearest values, the values that touch the boundaries of the land values. I created this raster, which represents just the coastline. And I was able to use this tool, the Euclidean allocation tool. And with that, this tool has two different inputs. The first one would be this raster without the land values. And the second input would be this one. So what the tool does is it interpolates values from these rasters in this area, giving me this output. So as you can see, there are no more land values in my output, so I would be able to fix the short line, the coastline. And this other slide is just to zoom into an area so you can see like I had red points, and it just like made the coastline thicker, so I would be able to fix the shoreline. So to fix the shoreline, I used a conditional tool, and my if statement was if the raster has a land value, I would get the value from this raster, and if it doesn't, it just keep the same value as the main raster. So with that, this would be my output. This is the converted ICE file to 1024 by 1024. And most of people would say like, most people would be unsure about the interpolation if it did work or not. So I would like to show this slide where I zoom into the Lake Superior. And I'm not talking about the lake's boundaries or the format of the lakes. I'm talking about the ice concentration. And as you can see, the left side, you can see the original file, and in the right side is the new 1024 by 1024 converted file. So the ice concentration looks alike, and I think the method worked. So after doing that, we were able to combine both files, the GLC with the NIC. And I used another conditional tool. If I had ice, I got my if statement was if the ice rasters has value greater than 0, which means there is ice, I would get that value from the ice rasters. And if it's not, I would get the GLC, so the surface water temperature. So this is my final result, is the combined files. As you can see, this is for the month of February, so it has a lot of ice on it. But if you would change to April, you can see like a lot of surface water temperature and just ice on the close to the Black Bay area. So in conclusion to that work, I would like to mention that the conversion to 1024 by 1024 permits a broad number of files in that format, facilitating analysis between them, for an example, from 1995 to 2006. And the combination of the GLC and ice cover will be very useful for making animations of surface water and ice. And finally, the additional years of combined data will help with model verification. So with that, does anyone has any questions? Thank you. Okay.
It seemed like the interpolation, when you zoomed in, it seemed like the interpolation to the bigger file size was great. I was just wondering, did you choose the extended year newspaper method?
Yeah.
Do you have an option to choose different interpolation methods, or was that just the one that worked?
I chose that one because it wouldn't change the values too much. I had the chance to use Cubico, or there's another one, I think it's majority, but I optioned it by the nearest neighbor because it just wouldn't change the values too much. Like it wouldn't create different values. Yeah, I did. I tried. Yeah. Yeah, that's right. Daily, yeah. So another, I think he used to work here. Is that correct? Dave Schwab was him that interpolated. Who interpolated? Oh, Ray. So Ray, a long time ago, interpolated the data, the ICE data. So we have like interpolated data for like daily data for that range of days. So I just got from the ICE Atlas from the GLERO website. What'd you say?
It was already,
Yeah, it was. It was already interpolated. Yeah, it was already daily.
I assume that same process of how to do it 2008 forward record, daily interpretation. Any other questions?
Is that it? All right. I would like to thank everybody, and hopefully my folks are watching to this, so I just would like to say that I love you guys, and thank you. Thanks, everyone.